Hello everyone, this is the last question of Trigonometric series. Hope you have gone through the rest of the questions very well. And this question is also as much important as the rest of the questions. And this will help you to get this get some different idea from the usual questions was exactly we solve. Like find the height of the like a building or the tower, find the base, the distance between the foot of the tower and something. These are some usual questions. This is something different. This question is from NCERT example, and this is one of the important question, or you can say this is one of the conceptual question which is not direct question, which is not direct based on the concept. So you have to apply something different, and this contains the concept of circle and the triangle. Triangle, that means trigonometric portion. So I'm just going to go through the question first, and then I'm going to explain how it is. I have already drawn here the figure. So moving on to the question, it says a spherical balloon of radius r. We have a balloon spherical in shape whose radius is r. Subtends an angle theta at the eye of an observer. Here A is any observer which is looking at this balloon, and this balloon subtends an angle theta, that this whole angle here. This whole angle, let me put some different colors so that you can clearly get what exactly I'm talking about here. This angle is theta if the angle of the elevation of its center is phi. The angle of elevation from the same point, I'm talking about from the same point, that means the observer is looking, and the angle of elevation of center, that is O, and it's phi here. It should be here, this point to this point. This is phi. Prove that the height of the center of the balloon is r sine phi into cosec theta by 2. You need to prove that this OB is equals, or you can say the height of the center of the balloon from the ground level, or you can say from the observer level, is r sine phi times cosec theta by 2. This is what you need to prove. So this is all about the question. Now I'm moving to the solution part. So as I told you, the solution part contains two different concepts. One is the circle and the second one is the trigonometry. So first let me go through the different parts. Here I'm just typing it along with the figure. Is it possible? Let me check whether I can. I think it's not possible to make it here, so I'm just writing here. As you can see here, angle PAQ is how much? Theta. You can see here angle PAQ is theta. You can clearly see. If PAQ is theta, that means angle OAQ will be equals OAP, and that will be equals theta by 2. Theta by 2, because you know in the tangents of the circle we have, if we have two different tangents from the same point which is lying outside the circle, the angle is always bisected between the tangents. That means this OA line will bisect the angle PAQ. The whole angle was theta, so it becomes theta by 2. This angle is theta by 2 and this angle is theta by 2. And the distance between this O, that is the center, and the observer is, suppose I have just taken it as OA, I have put some value, that is D. Second, we have the angle of the observer from the center at the angle of elevation, that is angle OAB is equals phi. This is already given in the question. I have not taken anything for granted. This is already given in the question. And second thing, the radius, that is OP, is R. This much information is always given. I have just taken the height, that is the OB is the height, which is taken as h. So exactly you need to find out the value of h. That means you have to prove that h is equals r sine phi into cosec theta by 2. So now just moving on. You know, in tangents, one of the tangent to the circle, we have one more question, that is radius is always perpendicular to tangent. That means angle OPA is 90 degree. So this can be taken as the perpendicular, or you can say the base, depending on the question, which particular angle you are talking about. So first I am moving in triangle OAP. Take at here, you need to find the relation between the radius and this hypotenuse, because hypotenuse is in both the triangles, that is OAP and OAB. So you have to find out the relation between radius and this. So here the angle is already bisected, that is theta by 2. So sine theta by 2 will be equal, sine theta by 2, that means this angle will be equal in this triangle OAP I am talking about. So that will be perpendicular, that is R, and the hypotenuse, that is OA, that is D. So just take it as equation number 1. Let it as it is, because it will be reduced in the next step. Now moving ahead here. Now I'm going in triangle OAB. Triangle OAB. This time we have angle how much? Phi. So again I'm going to take sine phi, because we need hypotenuse. So sine phi will be equals OB divided how much? OA. Now put the values. OB equals to how much? H, and OA is equals to D. So this is equation number 2. Because we don't need this D, so you have to remove that. We need H, we need R, we need sine phi, we need this sine theta by 2, with theta by 2 and phi, we need this. We don't need this, so what I'm going to do, I'm just going to divide equation 1 by equation 2, or you can say equation 2 by 1, because we need sec, so sign should be in division. So that means first I'm going to put this H upon D. This is the equation number 2, and here it was equation number 1. And the first one is R divided by D, which will be equals, first I have to put this one, that is sine phi, and then I have to put sine phi, and then I have to put this one, that is sine of theta by 2. So this D and this D will be cancelled out, and it will look like H divided R equals sine phi, and because 1 over sine is equals cosec, so it will be written as cosec theta by 2. Now because we need to find out the value of H, that is the height of the center, so R will go in multiplication, which will be equals to what we need to prove, that is R sine phi times with cosec theta by 2. This is what exactly you need to prove. Just get into quick recap. First of all, you have to read the question carefully, what exactly the demand of the question is. And the demand of the question is, you have a spherical balloon, have center O, radius R, subtending center at the two different tangents, subtending angle theta, and the base is subtending, center subtending at the angle base is phi. You need to prove that the center is at a height of r sine phi cosec theta by 2. So just take angle PAQ as theta and this as theta by 2 because it already bisect. Second OA equals to D, I have taken it so that it will be convenient. Angle OAB is phi, OP equals to R, that is radius of the circle. Now we have two different triangles where we can apply the concept of trigonometry. That is OAP, this right angle triangle, radius is always perpendicular to tangent. That is why it is right triangle. And second one is OAB. So in two different triangles, I have just put the values. Here sine theta by 2 equals to R over D, equation number 1. And here sine phi equals to H over D. I have divided second by the first. So it becomes H divided D divided R divided D equals sine phi divided sine theta by 2. D and D is cancelled out. It remains H divided R equals to sine phi into 1 over sine is equals to cosec theta by 2. Now this R was in division, so we'll go in multiplication. So H becomes H sine phi into cosec theta by 2. This is what exactly you need to prove. This is one of the not the newest question I can say, but it is coming for last 1 or 2 years and one of the hardest sets of CBSE, because this is board time. This time we have board, so you cannot expect anything easier, or you can say so some normal questions, or you can say some traditional questions. So hope this will be asked in one of the sets of the CBSE mathematics.